Cornwall's best kept engineering secret, DP Engineering. And Chris, I have to say, this is a fantastic machine shop. And just the workstation here, the guys have got touchscreen computers. It's just fantastic. And I think tying in with that, your latest acquisition, Citizen L20 LFV. Do you like it?
Yeah, definitely. It's definitely a major step forward from the machines that we had in the past.
Okay. So you've got a number of Citizens already, which were good machines, I'm assuming.
Yep. So this is our number 5 Citizen at the moment. So we had L20s before, but this is the latest version.
How's the machine changed then?
So the rapids are much faster, so we're gaining a lot of free time from that.
And more tooling in the machine?
There's a lot more tooling in this machine than the previous versions. Yeah.
And that's on main spindle. Sub spindle, you've got driven tooling as well, is that right?
We've now got live tooling on the sub spindle. So.
And in terms of axis, full B axis?
We've got the fixed changeable B axis on this machine.
Okay. So how does that help you in terms of manufacturing components?
Before we didn't have the option of drilling angled holes into components, and now we do.
Now, you also mentioned earlier off camera, Mitsubishi controls, they got a place in your heart.
It's the first CNC control that I work with, so personally I find it easier than other controls to use.
Right. So navigating around the G-code, everything like that?
Yeah. All the buttons are all in the same place as the previous machines, so it's continuity.
Right, so the upgrade hasn't involved changing everything around to confuse?
No. The screens all look the same, all in the same place, exactly where you want to find them.
Now, LFV, how's that changed things for you guys?
It's been a big game changer, so all the swarf problems that we used to have in the past that required high pressure coolant, thing of the past. So.
Okay, so this machine I'm assuming doesn't have, there is an option, but this machine doesn't have the high pressure coolant.
It doesn't have the high pressure coolant. We've still gone for the medium pressure coolant to aid drilling, but with the LFV, it now don't need it on the turn.
What about in terms of, I mean, this is new the LFV technology for you guys, in terms of actually programming and using the system, is that easy?
It's very simple codes, but you have got the options to vary the amount of LFV in the system. So if you turn it on to work to start with and you don't get the results you want, you can change some options to change it.
I suppose the best way to showcase how LFV has changed sort of the manufacturing process for you guys is, well, you've got the component here. How were you manufacturing that previously? And you probably can't give exact cycle times away, but give us an indication of how it's changed, please.
So we did used to have to make this on a M32 because we had the high pressure coolant with that. So peel turning to remove the swarf with high pressure coolant, and then
just to clarify, peel turning, is that where bigger chunks, bigger cuts, larger bits of swarf so it falls away?
Large depth of cut, and then adjusting the feed rate so that the swarf has the right weight to fall away from the component. But now with the L20 and the LFV, we don't need to do that anymore.
Okay, and I'm assuming then with the peel turning, you like I say, you're running at slower speeds, so again, increasing cycle time.
Yeah, it did increase the cycle time, yeah. So LFV, we're now back up to the feed rate recommended for the tool.
And also, previous process, you're doing a slotting threading one end, slotting the other end, 2 ops?
It was 2 ops, so our M32s didn't have the Y-axis capability, so when it came to machining the slot, we had to take it off and put it onto a mill. Now with this L20, we have the full Y-axis on the subspindle, live tooling, so that we can manufacture that slot in the free time where the component's been manufactured on the main spindle.
So music to every engineer's ears here, it's a free time.
Free time, gotta love it.
Okay. And also you mentioned link threading.
So before we were struggling with taper on the thread because it's more than 3 times the diameter of the component. We used to hold on to a sacrificial bobbin and then thread off the turret. But on the new programming for the L20s, we can link thread. So turn a section, thread a section, turn another section, pick up exactly on the thread and complete the thread in 2 passes.
Again, reducing cycle time, I'm assuming.
Definitely, yeah.
Okay, and with this, maybe a little bit contentious, tool life, is that improved?
The tool life did improve, but we've sacrificed that tool life for decreased cycle time instead.
So ultimately that has improved, but it's enables you to improve capacity, productivity.
Improve productivity by reducing the cycle time, yeah.
Now, well, one thing, you quoted the figures earlier, because before you were doing 250 of these parts during a day and then 250 overnight?
That's correct, but we've increased that now, so we're doing almost twice.
So doubling capacity through. And unmanned running, no, I mean, previously, were there issues or?
There's always issues with unmanned running with sliders, especially if you can't control the swarf on your components. So with the LFV, we've reduced those swarf issues, so we can now run longer into the evenings than we did previously.
So it's given you one small problem then. How to get rid? You've got to get rid of the swarf when it.
The swarf bin does weigh a lot with LFV chips. Yeah.
Not a bad problem to have though. So next, I'm presuming next slider will be a Citizen. Will it be LFV?
It will definitely be an LFV machine next time.
Chris, thank you very much. Cornwall's best kept engineering secret.